Hey Honors Algebra 2 students. Today we're going to be learning about 13.3 Sum and Difference of Angles Identities. Alright, so we have the sum and differences of angles for sine, cosine, and tangent, and you need to know these identities to be able to find a lot more angles or a lot more trig functions of angles. Because so far we just have our special angles like 30, 60, 45, and all the different quadrants that have those as reference angles. This will allow us to just expand that and be able to find a lot more trig functions with different angles. Okay, so we're going to do this a little bit out of order. The first thing I'm going to do is I'm going to have us try 1, 4, and 7, since those angles are the ones that we are kind of familiar with. All right, so think of it kind of like a warm-up. Okay, so for like number 1, we would go ahead and there's different ways you can do this. You can just look right on your unit circle and get the answer, or if you want to be a little clever, you can say, well, that's equal to sine of negative 30 degrees. And using one of your identities from, I think, our last lesson, that's equal to negative sine of 30 degrees. And that's equal to negative 1/2. All right, so different ways to do that one. Number 4, you have cosine of 135. Again, this you can get straight from your unit circle. You get negative rad 2 over 2. All right, and remember, so to use your unit circle, just in case you're not sure where I got that, you look at this angle right here of 135 degrees, and right there we have negative rad 2 over 2 and positive rad 2 over 2 as the coordinate on that point. Because it's cosine, we're looking at the x-coordinate, so that's where I got that answer. Okay, and then number 7, well, number 7 we can actually use number 4 to help us, because we know that cosine is an even function. That negative actually does nothing in a sense. Basically, I just mean that cosine of negative 135 degrees is equal to cosine of 135 degrees. So that's also equal to negative rad 2 over 2. All right, so just a little bit of warm-up just to make sure you have your unit circle close by as we go into some of these other questions. All right, so if you look at number 2, well, we don't have 165 degrees on our unit circle. So we're going to have to use our sum and difference of angle identities. All right, so the first thing I'm going to do is I'm still going to use the fact that cosine is an even function. And I know that cosine of negative 165 degrees is equal to cosine of 165 degrees. So that way I don't have to really worry about that negative. And then what you want to do is you want to rewrite 165 degrees in terms of angles that you do have on your unit circle. So I'm going to rewrite 165 as 135 plus 30. All right, so just kind of substituting 165 degrees with 135 degrees plus 30 degrees, and both of those angles are angles we have on our unit circle. Okay, so from there I'm going to go ahead and look at my identity for cosine and specifically for addition. So this is the one right here that I'm going to be using. And so this one says cosine of alpha plus beta is equal to cosine of alpha times cosine of beta minus, so notice that sign change, sine of alpha, sine of beta. So cosine, cosine minus sine, sine. All right, so I have cosine, cosine minus sine, sine. So this is going to be cosine, cosine minus sine, sine. All right, and then you use your unit circle to go ahead and find those values. So here I have negative rad 2 over 2. Cosine of 30 is going to give me rad 3 over 2. Sine of 135 is rad 2 over 2. And sine of 30 is 1/2. All right, and that simplifies. This is going to be negative rad 6 over 4. When I multiply these two together, when I multiply those two together, I get rad 2 over 4. And go ahead and simplify that further, get that common denominator already there. So I get final answer, negative rad 6 minus rad 2 all over 4. And that is my final answer. Okay, not the prettiest, but that's it. Okay, let's go ahead and let's do another one. Let's jump to number 8. All right, so number 8, we have sine of 75 degrees. Excuse me. And let's go ahead and rewrite that 75 degrees into angles we have on our unit circle. So hopefully you're thinking sine of 30 degrees plus 45 degrees. All right, so for sine, my double angle formula up here tells me that if I'm adding, I'm going to go ahead and do sine cosine plus cosine sine. All right, so those signs match when it comes to sine. They're opposite when it's cosine. All right, so sine cosine plus cosine sine. Sine cosine plus cosine sine. All right, so then I have sine, the first angle, cosine of the second angle, plus cosine of the first angle, and sine of the second angle. Okay, and then refer to your unit circle. Sine of 30 degrees, I got 1/2. Cosine of 45, I got rad 2 over 2. Cosine of 30, I get rad 3 over 2, and sine of 45 degrees, I get rad 2 over 2. Multiplying those, I get rad 2 over 4 plus rad 6 over 4, giving me final answer of rad 2 plus rad 6 all over 4. All right, and that is my final answer. Oops. There it is. Okay. All right, so why don't you guys practice that a little bit with numbers 3, 5, 6, and 9. And once you are ready, go ahead and unpause the video, and then you can see if you got the right answers. All right, if you are ready for the answers, here we go. Starting with number 3. And these are pretty quick, so I'll go ahead and work these out with you. Okay, so sine of negative 225 degrees. Negative 225 would land me right around here. All right, negative, so I'm going to go clockwise on that one, and that gets me a reference angle of 45 degrees here. All right, so again, looking at your unit circle, and specifically at the y coordinate right there, we get rad 2 over 2, positive. Okay, and then number 4, I have sine of negative 45 degrees. All right, so because sine is an odd function, I know that's equal to negative sine of 45 degrees. And sine of 45 degrees is rad 2 over 2. So final answer I have is negative rad 2 over 2. All right, and then we have cosine of 210 degrees. So 210 positive lands me right around here with a reference angle of 30 degrees. All right, And then if you look at your unit circle, you can see that that's going to be equal to negative rad 3 over 2, looking at the x-coordinate, because we were talking about cosine. Okay. And lastly, number 9, we actually haven't used any of that sum difference identity yet. So number 9, let's go ahead and do this one out. Again, sine is an odd function, so I'm going to pull out that negative, and I get sine of 1, or excuse me, negative sine of 195 degrees. All right, and so I'm going to save that negative for the end, and I'm going to rewrite sine of 195 degrees to be sine of 135 degrees plus 60 degrees. All right, and then looking back at the sum and difference identity, this one's also, sine, cosine plus cosine, sine. So this is going to be sine, cosine plus cosine, oops, wrong angle, sine, all right, and then now we're going to look at our unit circle. So sine of 135 degrees, this is going to be rad 2 over 2. Cosine of 60 is 1/2. Cosine of 135 degrees is negative rad 2 over 2. And sine of 60 degrees is rad 3 over 2. Okay, let's go ahead and simplify that. This is going to be rad 2 minus rad 6, all over the common denominator of 4. But because of that negative, which I was carefully kind of bringing down along with me, I'm going to go ahead, and this can be negative rad 2 plus rad 6, or if you like, I like having the positive in the front. So I'm going to do rad 6 minus rad 2 over 4 as my final answer. I mean, if you wrote it as negative rad 2 plus rad 6, same thing. So either of these would work. Okay, so hopefully you guys are a little more used to these sum and difference identities. Let's go ahead and go to this last section, numbers 10 through 15. And, oh, where's my number 10? There it is. Sorry about that. All right, so it says verify that each equation is an identity. All right, I like these verification problems. They're great because you pretty much know if you got it right. They kind of give you the answer. You just have to kind of fill in the steps between the left-hand side and the right-hand side. All right, so because it's a proof, again, you do want to make sure that you show all the steps in this proof. All right, so let me go ahead and do the even ones, and then I'll have you guys practice with the odd ones. All right, so for number 10, this is clearly using the sum for the sine trig function identity. So I have sine, cosine, plus cosine, sine for my left-hand side. And sine of 90 degrees, if you look at your unit circle, is just 1. And cosine of 90 degrees is 0. So this simplifies just down to cosine of theta, which is equal to the right-hand side of cosine of theta. So that checks out. Okay, number 12. All right, so number 12, we have the cosine of the difference of angle identity. So this is going to be cosine, cosine plus sine, sine. All right, so cosine, cosine plus sine, sine. All right, and then cosine of 270 is 0. And then sine of 270 is negative 1. So that simplifies down to negative sine of theta, which is what we wanted to show. So there it is. All right, and number 14, this is going to be sine, cosine, minus cosine, sine. All right, this is in radians. Okay, but pi over 2 is just 90 degrees, so you want to look at your unit circle at 90 degrees, and the x-coordinate for cosine is 0 there, and the y-coordinate for sine is equal to 1. So this simplifies down to cosine, drop my theta, no floating trig functions, and that's your verification. Okay, so hopefully you guys get a good handle on that. Why don't you go ahead and pause the video, and once you're ready, go ahead and unpause. You can check your steps with me and see if you got the same thing. All right, here are the answers for 11, 13, and 15. Here we go. Number 11, I have sine of 180 degrees, cosine of theta, plus cosine of 180 degrees, keep doing that, and then sine of theta. All right, sine of 180 is 0, cosine of 180 is negative 1, and so that simplifies down to negative sine of theta, which is what we were hoping for. Okay, number 13, we got cosine, plus sine, and cosine of 90 degrees is going to be 0, sine of 90 degrees is 1, so that simplifies down to sine of theta, which is what we were hoping for. All right, and that is number 13. And you guys might be wondering, like, oh, will they ever give me something where it doesn't equal to the other side? No, that won't happen because it says verify, meaning that it is definitely true, and it's just your job to show it. So no trick questions where the right-hand side will not work out. Okay, let's do this last one, number 15. We got cosine, minus sine, and cosine of pi is negative 1. Pi is just 180 degrees, so look at your unit circle. And we got sine, which is 0 at pi. So this simplifies down to negative cosine of theta, which is what we were hoping for. All right, so hopefully you guys are getting more comfortable with those sum and difference identities, and this is it for lesson 3 of chapter 13.